Okay, so yeah, thanks for introducing me. It's really nice to be here and talk to the IEEE Young Professionals Bangladesh. Uh, Let me just get ready. So yeah, I'm gonna start sharing my slides. Can you see my slide?
Yes.
Okay. Okay. So I guess we can get into the topic. So basically, today I'm going to talk about this uh, exciting topic. We all know that computer vision is becoming big. And so the title of my talk today is Machines Can See Now What's Coming, What's Next. And I'm going to try to cover the current state of computer vision research and also some use cases, as well as I'll try to show some futuristic use cases and try to kind of predict what's going to come in the future. Also, I'll talk a little bit about like how we can get more involved with this progress of computer vision. So let me give let me introduce myself. So as Sajid already mentioned, I'm currently a senior engineer at Qualcomm. And my research area at Qualcomm is basically I develop computer vision algorithms for the mobile platform. And recently I'm also working on their extended reality I'm also doing R&D for their extended reality applications. I did my PhD from University of Maryland, and also did a bachelor and a master's from the Department of Electrical and Electronic Engineering at BUET. My key research areas and also interests are in active or continuous authentication, detection, recognition, verification. That includes like object detection and face detection, face verification. I have done a little, I worked a little bit on 3D pose estimation, very interested in reinforcement learning, did some projects. The image enhancement and speech enhancement are some of my other expertise. So here is a brief outline of what I'm going to talk about today. So at the beginning, for the general audience, I'd try to very simply explain how machines can see. And then I'll talk about how computer vision affects our daily lives. Now COVID-19 is the pandemic is going on worldwide, and I'm going to focus a little bit on how that the pandemic is actually dictating the trend of computer vision research. Then comes the major part of my talk, what's going to come next, and followed by how we can get more involved in computer vision research and the way forward from here on. So how do machines see? So this is first of all, this is a very simplified diagram. Real systems are more complicated and much more interesting. A machine basically sees by using some sort of sensing device to capture a snapshot of a scene or an object. It can be in the visible color spectrum. It can be infrared domain, or maybe a thermal imaging. But the idea is there should be some sort of sensing device, much like human eyes. And then there should be a processor or an interpreter which tries to mimic human brain and interpret the scenario or the situation that is being captured by the sensing device. So in this very simple example, an interpreter can interpret this scene as it having an animal in the scene. The animal is a frog, which is an amphibian. It is sitting, that's related to its pose or pose, then or the gesture or the action it is performing. Then the color information, the color of the object is golden. There are green trees in the background. mud can be seen in the scene. Also, even the sensor might give it information about the depth of the scene, saying that the frog is actually in the front, the trees are in the back. So computer vision basically, like the computer vision algorithms basically are these algorithms to interpret what the sensing device is providing us. And it has been like very fundamental in many recent applications. For example, I have a list of some uh, like real life experience directly you can associate with some sort of application of computer vision. For example, of course, in social media, we spend a lot of time. And as you upload a photo, you see that Facebook automatically detects the faces, and not only detect them, it also actually matches it with all your friends' images in your friend list, and then suggests tags. All of these are actually very good real life applications of computer vision. In entertainment or in communication, right now we are talking over Zoom, and I'm using a virtual background. Basically, a segmentation algorithm is segmenting my face and the body from the background, and then we are and then it is basically placing uh, a virtual background in the back. Avatars and emojis are very good examples, especially in emoji. Uh, it requires face detection, then facial landmark detection, also facial landmark and face tracking across frames. And then also you need to kind of determine how the landmarks are changing, and then fit an animated character or some sort of animation on top of that. So very, very challenging and interesting recent use cases of computer vision. In security, face unlock has been very popular. Also, now smart homes are becoming a reality nowadays. So it's very important to have like good security system, and biometric security, especially using faces, is one way to go. Smartphone photography allows you to do face and smile detection. And then there is also this portrait or face bokeh mode, where the phone actually can focus on the face, making the background all blurry. And that is a very interesting and nice use case of computer vision. So in the same way, computer vision is being used in video streaming to compress, in movies to provide advanced photo editing capabilities. Virtual reality is going to be a real big thing, and already there are virtual reality devices available. In transportation, in autonomous driving, there are lots of vision sensors on all sides of the car, and the computer vision algorithms are used to infer all sorts of information about the surrounding of a car. Also inside the car, there are cameras to monitor driver. In banking, actually, I in fact forgot last time when I went to a bank in the US. Basically, uh, I can to deposit a check, you can take the photo of the front and the back of the check, and the banking apps have computer vision algorithms in the cloud, which verifies the check in this in an instance. So that's been a very big use case for computer vision algorithms in banking. In law enforcement, face recognition, license plate detection are common use cases. And finally, in industry, monitoring infrastructure structures with like cameras is a popular use case, especially to basically monitoring the health of the infrastructure in the, for visible wear and tear. So moving on, now COVID-19, the pandemic is affecting all of our lives, and it is also kind of, I'd say, dictating the current computer vision research trend. So I'll basically focus on three aspects of it, but there are, I mean, there might be indirect influence on some other aspects. Uh, so I'll basically focus on vision-based authentication, touchless technology, and the computer vision for healthcare. So in vision-based authentication, masked face has come out as a very big challenge. So facial recognition anyway was going very big, and it was projected to be a 10.9 billion US dollar global market by 2025. But when COVID-19 like hit the world, everybody started to wear a mask, and that had made it very difficult for the uh, for the like uh, for the developers of facial recognition technologies to cope up. For example, face unlock was very popular. So Apple actually recently brought a software update to make sure that if the face unlock doesn't work because you are wearing a mask, you don't have to like keep trying to do face unlock for multiple times before you are asked for a pin. This update basically kind of bypasses the face unlock. Uh, also, also Uber launched a technology in India to check if the drivers are wearing a facial mask. So basically, it opened up new research challenge, like how to detect a masked face, how to properly authenticate or recognize a masked face, and also how to uh, basically even detect a mask is a research challenge. And since this is very recent, there are not many uh, data sets available on this. I found this very recent data set that is collected by a research team in Wuhan University. It's called Real World Masked Face Dataset, and these examples are actually from that data set. So it has around 5,000 real world masked faces, while 90,000 normal faces. So still, the ratio wise, it's like a pretty small number of masked faces, I would say. Uh, and then though it also simulates masked face on real face data sets. So, and the authors of this data set also proposed a model that achieves up to 95% accuracy, but for real applications of facial recognition and face-based authentication, this accuracy, I mean, it requires even more rigorous evaluation. So right now there is a lack of proper wild and unbiased data set in this area. Moving on, now there is an increased demand for touchless technology, and that's entirely due to this pandemic. And some companies already responded to that. For example, Ultraleap already introduced gesture controlled kiosks. Basically, if you say, if you go to a bank to use the ATM machine, you don't actually have to touch the panels. Rather, it will allow you to use your gesture to interact with the device. So I mean, these are not exactly already implemented, but they already developed such technology. Others such technologies include touchless elevator buttons, touchless medical interfaces. So touchless medical interfaces are like for medical personnel to use in a hospital where it is like a high risk area, so the doctors don't actually have to use the same touch screen over and over again, or rather they can use the gesture to interact with the touch screen. There are the detection of gesture and like tracking of like hand is already a pretty difficult problem to solve for real life. Additional challenges include the cost of such technology, and also for ease of use for people to adopt such technology, it needs to be very precise, because you don't want to do the same gesture over and over again to make the machine understand. So those sort of challenges actually pops up for when you want to deploy such technology like in a mass scale. The market is going to grow, expected to grow to up to 15.3 billion USD 2025. The third topic I want to discuss about is how the pandemic actually influenced using computer vision algorithms for disease control. And that happened in multiple branches. So computer vision is now being used for diagnosing COVID-19 using X-ray and CT scan images. It is also being used for prevention and control of COVID-19, basically vital sign monitoring from a distance, such as mass fever monitoring using infrared thermography. And also there is this concept of pandemic drones to provide support to highly infected areas without human intervention. Also, in clinical management and treatment, computer vision is being used, for example, for patient screening from a distance, or also say fast and accurate 3D modeling of a healthcare equipment, so that it can easily be printed using a 3D printer, monitoring abnormal breathing pattern and such others. So again, one major issue here is that there are limited annotated data for many of these tasks. For example, for disease diagnosis, there are still not much available data for training, say, a deep neural network based classification model that would classify the CT scan images as healthy, non-COVID infection or COVID-19 infected patients. But researchers are exploring ideas like transfer learning from pre-trained models, or weakly supervised learning to be able to train with limited annotated data. There are also some other concerns about it, such as in fact, in medical, in healthcare, the deep neural networks are actually in many cases not well adapted because of their lack of explainability. But I'll touch on that topic a little later. Okay, so yeah, I'll just take a brief pause to see. Okay, so moving on, let's take a look at what's gonna come next. So yeah, on the right, I'm showing a scene from the movie Back to the Future 2, where you can see a digital object being projected in the physical world as a hologram, like a holographic projection. This is kind of like a mixed reality, and this sort of technology are not that far away actually. So this movie was made in 1989, and at that time nobody imagined that the like augmented or reality and mixed reality and virtual reality will come this far. So basically, I'm gonna touch on a few topics. I'll talk about smarter homes, what sort of amenities they will have, and then how security is gonna get enhanced. There are awesome assistive technology for disabled people that you can expect to see in the near future. XR revolution is right now going on, and that's something I'd say the XR revolution is also another thing that is directly being promoted by this COVID-19 pandemic. Autonomous and smart vehicles are, there are a lot of research going on in this area, so hopefully we'll some of those. There is a revolution going on in visual effects. Explainable AI is a very interesting topic that's gonna be a big thing in the future. And then finally, artificial general intelligence. I'll touch a little bit about that. Also, I'm gonna talk about the dark sides of this advancement of computer vision, how it can also adversely affect our lives. So let's get started. So smarter homes. Smart homes has been there for as a concept, and also there are partially smart homes already, like technology for creating a partially smart homes already available. However, it's still missing some key things, and also when we say something is smart, it doesn't always mean that thing that thing is very smart. Most of the cases, all the use cases of this machine learning or deep learning techniques that we see are kind of like are basically models that are trained to do a particular task. But to become more smart, these homes actually have to combine information from different sources to kind of model each of its occupants separately. So basically, a smarter home should have enhanced security, say biometric authentication, face recognition, but there should also be predictive action modeling. It should be able to kind of predict or like detect anomaly that is going on outside the house and alert the residents inside. Also, indoor activity monitoring also requires some sort of predictive modeling. For example, the home should have indoor activity monitoring system that would track all the individual, will detect events like someone falling down or a baby crying, and then inform the like responsible occupants of the house. Or it should also be able to detect all sorts of other anomalous and hazardous condition. Also, interaction with the objects in the home will be done by using gesture and voice control. So we know that devices like Amazon Echo is already there, and it gives a very little it provides some like provision for controlling your devices with your voice. If you connect it with your thermostat, like at my home, I have connected it with the thermostat of the house, and I can give it a command to turn on the AC or turn on the heater and set it to a certain temperature. But it has to go a lot further. You need to be able to control everything, including your TV, what channels you want to watch, what show you want to watch, the lighting, if you want it to be dimmer, brighter, the window blinds and everything. If all the entertainment system, even your you should be able to interact with all other devices like your washing machine, your refrigerator, even your bed. And then recommender system is then comes into play. For example, we already know that Netflix recommends, it kind of always tracks the user's behavior, user's choices, and recommends new TV shows or movies according to your your prior behavior. For so that goes for TV or media contents, but also the smarter home should be able to combine all the information about a person it is getting from all the interactions that the person is doing with different devices, in his house, and it should be able to build a model of that person and try to predict like what that person would like. For example, if you enter into another room, if you go to another room, the smart home system should detect that you are like Mr. A getting into that room. So it should automatically set all the settings of all appliances in that room according to your preference. So that sort of technology is gonna look even smarter than our current smart homes. Monitoring is gonna be a real part of it. Smart toilets that would basically analyze all the disposals and uh, determine your current health status. Also, there are other concepts that might come into play, like temperature regulating smart fabric. And also, and all these, again, what I was mentioned comes to that point where everything should be connected internally and maybe even with, and also with the cloud to do faster processing. So connected devices, tailoring the home according to a person's preference based on all this information is something that we can expect to see in the future. Major challenge in this area is preserving information privacy. Of course, nobody wants to give all the information to the house. You might also not like the home tracking you all the time. But computer vision is obviously going to play a huge role in this whole scenario in health monitoring. Smart robots, robotic assistants in the house with vision sensors are gonna be like very big in the future. Also in the security system, indoor activity monitoring system, everywhere you'll be able to see direct usage of computer vision technologies. Now let's come to enhanced security. So we have smarter homes and the home needs to be very secure. So image or face-based security system are being developed. They're already kind of there. You'll probably be able to see like CSI, like enhancement capability. Now there are many researchers going on image super resolution. So even if you have a very tiny small face in a big photo, you can actually enhance the resolution many times and do a much more reliable authentication right now. So that technology is almost already there. But what I mean by enhanced security is actually of no password full biometric security. So on the right side, I'm just showing all the sensors that are available on a smartphone. So there is this concept of active or continuous authentication. Basically, that my PhD was on that topic. And the basic idea is instead of you providing your Face ID, you providing your password to the phone to do an one-time authentication, the phone will actually authenticate you based on your behavior or your pattern of interacting with the phone, or based on all the sensor, all data from a lot of sensor that the phone already has. For example, it can use the front camera to capture the face of the person using it. It will use the accelerometer and gyroscope to see if this the motion of the phone, the model of the motion actually matches with the or the original user of the phone. It will be able to verify the user based on the swipe gesture, or even with the location and app preference will come into play. So all of this information, when combined together, will have a truly robust authentication system that will be very hard to spoof, because unless you totally change a person to another person, it will be very difficult to spoof that, like very difficult to mimic all sorts of interaction a person will do with the phone. So that sort of enhanced security has some challenges. For example, there are not much realistic data available for doing such research. Also, power consumption is a big issue. So, and not smartphone is one example. The same can probably be done for many other things. Even for smart homes, the smart home can always track an individual inside the house. It can also track the individual's behavior to determine if that is actually an individual or an impersonator, an intruder in the house impersonating as one of the occupants. So that would be some sort of enhanced security, and there are already many research works going on this topic. We are going to see awesome assistive technologies, and for example, so first of all, this is a very big global market. By 2024, the market is going to grow up to 30.82 billion worldwide. And if you are not familiar with it, these assistive technologies are technologies to help, say, visually impaired people, or like people with any sort of disabilities. So, for example, Microsoft Sensing AI is an app that can actually provide audio description of a scene to a visually impaired person. It can recognize friends, describe their facial expressions to him or her. It can read handwritten or typed texts. It can read currency bills. It can help scan barcodes on product, capture and save documents, and all these things. These are already out there. What it lacks right now is contextual awareness. Context is something very important, and even if you see a photo uploaded on Facebook, that only describing that photo does not tell you everything about the situation. So there has to be, it has to be, first of all, it probably has to be multimodal, not only looking at the photo, but also analyzing all the texts that came in the photo, as well as it might also require like analyzing, say, all the photos in an album, even the comments on under the photo, to understand what's really going on. So that's sort of contextual awareness is right now not there for the assistive technologies. Also, privacy is a big issue in this area because, as I mentioned, it can recognize friends and describe facial expression, and that means that it is actually going to store information about another person in the of that blind person, and that might be an invasion to the privacy of that person. So there are researchers going on to kind of abstract the data in such a way that it will be preserving privacy. Right now, personalized service are not there. Microsoft Sensing AI is a very generic app for assisting disabled people. But people may have different health conditions, different sort of disabilities. So it has to be customized to match the needs of each individual separately. Navigation assistant is probably a low-hanging fruit that can be achieved sooner. Actually, I'm not aware if such thing is already there for visually impaired, but it might be. First of all, unbiased estimation is something important because, as you know, dataset bias is a common problem in computer vision. And if that bias exists, and if the assistive technology has that bias, then when helping a disabled person, it can propagate that bias to the disabled person. So we don't want that. We don't want the assistive technology to be biased about race or gender or age or any other information. So unbiased estimation of a scene or providing unbiased description of a photo is something the researchers are working on. Now, XR came as a revolution. So if you're not familiar, XR means extended reality, and basically it addresses three things: virtual reality, augmented reality, and mixed reality. you're probably familiar with virtual reality, which is which basically an immersive experience in a fully digital world. Augmented reality is will be some digital object overlaid on the physical world. Say through your phone, you'll be able to see a character walking on your table, something like that. Even though that character is not in the physical world, that digital character will be there. This involves like plane detection, object detection, and on top of that plane, the computer vision algorithm will actually put the like digital content. And then mixed reality is actually physical interaction with digital objects. So if you are able to push that digital object with your physical hand, then that becomes a mixed reality. So global XR market actually estimated to reach $393 billion by 2025, which is extremely big. And COVID-19 is actually pushing it, because right now we are getting more dependent on all this like virtual or augmented reality technology for many reasons, like virtual meetings are there. And so I'll touch on that. But before getting there, for best XR experience, there are some things you need, like real-time visuals overlaying reality. That means real-time computation, heavy computation. Then immersive audio, natural interaction ability. Natural interaction ability is directly associated with computer vision, because say you want to interact with a digital object with your hand. That requires a computer vision algorithm to use the sensors on the virtual reality or augmented reality device to detect your hand and kind of find the hand pose and see what, and also interpret what you are trying to do, whether you are trying to pinch, grab something, throw something, all these interactions. Intelligent AI is of course needed, and then untethered connectivity. So because you don't want it to be the connectivity to get interrupted all the time, you want a very smooth, seamless experience. So I work at Qualcomm, and Qualcomm actually is XR. It is right now all the major players in this XR market, like Google with their Google Glass, Oculus Quest with their Oculus Quest device, and Microsoft HoloLens. They are all using Qualcomm Snapdragon processors to power this, as the core processor for all these devices. So so here are the big challenges associated with XR technology. We want comfortably wearable devices. It requires intense computation, longer battery life, low latency, and boundless XR is a big challenge. So what is boundless XR? Basically, you don't want your XR device to be connected with a computer. You want to move freely inside your home. And that means that the device has to process everything either on device, or it has to connect to the cloud. So there is some processing involved on the edge device and some processing involved on the cloud. And Qualcomm, with its 5G technology and its Snapdragon processors, is actually working towards making it a reality. So I have a small video on that here. Boundless XR, Qualcomm actually Qualcomm brought a cheap a dedicated chip for the XR technology. That was XR1. Now they also promised to bring XR2, and in the next video you'll see how XR2 is gonna bring a revolution in the XR industry. So it will have 7 concurrent cameras, 8K 360 video, 2K resolution per eye. And if you look at these use cases, 3D reconstruction, semantic segmentation of the scene, automatic room mapping, everything involves application of computer vision algorithms. Require plain detection and other computation algorithms. Okay, so then comes autonomous and smart vehicles. Basically, autonomous vehicles have a pretty big market, projected to be 556 billion US dollars by 2026. And there are a lot of computer vision research going on this area. For example, on the right, you can see an example of semantic segmentation of a road. All the cars, trees, grass, everything is segmented. The road, the sky, everything is segmented to level. And so there are already researchers going on this. Also, it requires smart object detection and tracking, predictive modeling. Like if someone is crossing the road, you have to predict where that person would be in the next second. Anomaly detection, scene understanding, multi-view 3D reconstruction, mapping, localization. I've also mentioned probably driver monitoring. Actually, not driver monitoring. Smart vehicles are going to be like smart homes. It will be able to monitor every occupant in a vehicle to provide them the best in-vehicle experience. So that sort of technology we can expect to see soon. Then there is a revolution going on in visual effects. So in Hollywood, they used to spend a lot of dollars, a lot of money to do all sorts of CGI animations and special visual effects. Now, computer vision in recent years with advanced deep learning capabilities have brought a few very interesting visual editing tools. So I'm going to show a few examples here. And the left one is called Gauguin. This is basically a tool to create photorealistic images only by sketching. So in the left, like left of the left video, you see that some person is doing some line drawing, annotating that, okay, green is this set of trees, then he's drawing the mountain right there, and then blue is the water, another shade of blue is the sky. And then on the right, the computer vision algorithm is automatically creating a photorealistic image using that input, using that very basic line drawing input. On the right, you can see an example of image in painting. Basically, it allows you to mark areas in the photo that you want to remove, like or smoothen. And if you see that only by painting with your mouse, you can even remove the mustache in Einstein's face. And in Hollywood, for many visual effects or many visual editing tasks, they actually have to spend a lot of man-hour and money to do similar kind of to achieve similar kind of visual effects. So once this sort of technology is adopted by Hollywood, which already has begun, you'll be able to see like the production cost will basically go down a lot. This almost comes free of cost compared to like several thousand dollars that is currently needed. Also, uh, there has been there are these face swapping or deep fake technologies that are currently pretty popular. So you can copy the expression of a person's face to another person's face, uh, and make them kind of like, if you see here, all of these faces are basically copying the same expression of the first person in the very left. And this is like very natural looking short face, very difficult to identify that this is a fake face. So this sort of technology is going to revolutionize the movie making industry. Also, neural style transfer is here. So in the right example, the first column is an input image. The second column is a styling image. And the result of the style transfer using a deep neural network based style transfer method is the third image. As you can see, the input image is modified to follow the style of the image sample. And this sort of technology is, for example, actually I can give you a straightforward example on that. I was recently watching a TV series called Undone on Amazon Prime, where uh, the real actors acted, but they had to change every frame manually to make it look like a drawing. But such similar effect can be achieved by using a neural style transfer ring method uh, at a very, very low cost. And since you don't have to do it manually for every frame, it will be done automatically. I mean, converting the whole movie might be a matter of several hours instead of like a year or multiple months. So that sort of change, revolution in visual effects we can expect to see in the future. Then explainable AI or XAI is a concept. So as I mentioned earlier, that many fields like the medical field, like our healthcare field, they're kind of skeptical about adopting machine learning or deep learning algorithms for doing, say, disease diagnosis, because the methods do not provide enough explanation of why they are diagnosing like this. So there are many research going on in this area. For example, in the right side, you can see that given these photos as input, the photos in the top row, the network predicted that this action is the action of cutting trees. And the researchers actually were able to extract the information in the bottom, showing what area of the image actually influenced that decision. And you can clearly see that the neural network actually was able to put its focus on the saw, the tree area, and the person's head to come to that decision. So that's kind of like an explanation from the network's part that, yeah, based on all these major activities, I am saying that this is the cutting tree example. Similar thing, another example is given on the left, bottom left. So the network not only says that this image is the image of a bird, but it also gives a text description, a reason in text saying why it thinks that it is a certain bird, saying that this is a western grebe because this bird has a long white neck, pointy yellow beak, and red eye. So that sort of explainable AI will be more popular in the future and will be adopted in the healthcare industry. Finally, artificial general intelligence means that artificial intelligence performing or outperforming human level performance is I'd say it's a far-fetched dream right now, but in some areas, it has already been achieved. For example, this graph is from Google's DeepMind. So they trained reinforcement learning agents to play the Atari games. There are 57 of such games, and so if you look at the graph, the y-axis actually shows that in how many games the agent actually outperformed humans. So up until recently, they were able to outperform in around 52 games, but very recently, like a few months back, they were able to outperform humans in all of the 57 games, making so that means that that single gaming agent was able to do better than human benchmark in all of the Atari games. And also, you probably are familiar with the reinforcement learning agents that defeated the world champions in chess and Go. So even though it is right now being explored in this game related tasks, but artificial general intelligence is gonna be something that is kind of like the ultimate goal for many of this research. Now let's look at the dark side. So, and the dark sides are not always bad because they open up more exciting research opportunities. So I talked about issues in training data, which can, for example, bias in training data led to misidentification of people as criminals. There has been many recent incidents like that in the US. So reducing dataset bias is a very interesting research area. Ethical use of outcome, for example, deep fakes are actually kind of dangerous technology if in the wrong hands. So deep fake and data manipulation, how to prevent that, how to easily detect deep fake and manipulated data, that's an interesting research area. Privacy preserving computer vision is going to be a very important research area. How to abstract information, how to prevent spoofing, how to, and then the health impact of long-term use of computer vision technologies is an interesting research. And also, of course, robots are becoming too intelligent. So rise of the robots and end of humanity is probably something many people are concerned about. So there are some agents that already passed the Turing test in 20. Yeah, I guess robots becoming too intelligent is still, we don't have to be very scared about that. So also these dark sides can really impact our lives. So if you see in the next slide, so Tesla Model S had a fatal crash in May 2016. And it was interesting from a researcher's perspective, because what happened here, if you see at this top left image, this big lorry was actually taking a left turn from the highway to a kind of like another road. And the Tesla was coming from the left. And neither the autopilot, it was running on autopilot, and the driver actually was not running on autopilot. I think he just went to autopilot for like a very small, like 20-30 seconds back. And it did not see the car because the car was very high. So you can actually see the road under the car. So the autopilot thought that it's still a road, and the color of the car actually matched with the sky color. So it thought that there is no car. And that mistake, actually what happened is that the car went underneath the lorry, and then it eventually veered off-road and strike two fences, and you can see what happened. Basically, the top part was all smashed, and the driver died. So so that actually kind of prompted uh, like brought more changes in the research on autonomous driving. They now have radars, like short distance and long distance radars, and multiple cameras and ultrasonic sensors to uh, kind of ensure that this sort of thing doesn't happen. But I mean, this is an example of probably too early adaptation of a technology. And there are so many corner cases that happen on the road, that can happen on the road. So uh, I guess when doing research in these areas, we'll have to also make sure that we evaluate our results properly or have some technology to kind of make the right decision in confusing situations. So yeah, so now let's just, I guess I have only a few minutes left. I'll briefly talk about how you can get involved. I think the best way to get involved is to collect and annotate a lot of data, because there is a scarcity of data. Deep neural networks are data hungry and they can take in a lot of data, but there are not too much data on smartphone usage. From Bangladesh's perspective, I'd say videos of roads and highways, if they are annotated for semantic segmentation, that would be a very valuable data set, because roads in Dhaka are not like the roads in the USA. So they actually would unveil a lot more challenge. Testing an autonomous driving agent on such road condition is gonna be kind of like the ultimate test for autonomous driving cars. So that sort of data, if can be collected, will be very valuable. Face data sets are easier to collect. Everyone has a smartphone, and there are not too many data sets on Southeast Asian faces. And as you know, data set bias is always present. So the more data of all sorts of ethnicity we can collect, the easier it would be to train unbiased estimators. Surveillance data from train station and bus terminals, airports in Bangladesh will be very valuable, because again, those are very difficult situations. A lot of people are there, and the type of tasks people do is like crowd counting, person tracking, anomaly detection, and for all of these tasks, these are going to be like kind of the hardest type of scenarios one has ever seen. Also, cluttered scenes with a lot of objects that are related to our culture, unforeseen objects in US context. If they are annotated properly, that can actually drive many computer vision related research. And on that topic, I don't know if you're familiar with this selfie. This was called the world's largest selfie, powered by Lumia 730. This was a group shot of around 1,100 people. It was taken in Dhaka in November 2014. And if you don't know, this image is being regularly used by the computer vision research community to showcase the power of tiny face detection, because this one has a lot of tiny faces. And even this image was actually collected from Dr. Deva Ramanan's paper in CVPR 2017. They ran their face detector network on this image and produced this one. So definitely, as I was mentioning, such cases, collecting this sort of very difficult corner cases is gonna be very influential for the computer vision research community. So finally, my last slide, the way forward would be to explore and innovate. We need to innovate and explore new use cases of existing computer vision technology in the context of Bangladesh. Also look into new topics, brainstorm new ideas that might only fit Bangladesh, but still, as long as that's a new idea, a new way of doing something, that is gonna be very valuable for the entire research community in the world. And of course, we need to get involved in developing new technologies to to make sure that computer vision spreads even more and touches every person on earth. So yeah, with that, thank you for listening to my talk. If you have any questions, I'll be happy to answer.
Thank you very much, Upal, for the nice talk. So I don't see any questions in the chat box. So if you have any questions, maybe you can just use the raise hand option. Or do any of you have any questions? You're welcome to unmute your mic and ask the first question. So I guess the Upal, I can ask the first question. So you've mentioned some of the ethical issues of computer vision, and what about if I mean it even as an authoritarian regime or authoritative government, they start abusing the power. So you know, in China, they're trying to implement like very strict rule and like mass surveillance or those kinds of things. So is there any way out like for this?
So I mean, I'd say so this is an entirely ethical issue, right? So of course we want this sort of surveillance technology to be in place for people's safety, but as I mentioned earlier, I think that in the wrong hand, it can create it can be very deadly, or it can harm people in many ways. So I guess there has to be some sort of like check and balance to ensure that misuse of technology is not done, but I agree that it is very difficult. There is, right now I don't see any straightforward way other than imposing some like global rule on such things to prevent that. Like for example, even like it's like face-based authentication or recognition technology is being used in the US for a long time now, and that has led to many misidentification of mostly people with color, because there was some dataset bias present in when training those methods, and it in like kind of ruined the life of many people. So now there are like many people are thinking more about how to prevent such incidents, and hopefully we'll be seeing more ethical use of computer vision and like AI in general in the future.
Thank you very much. Is there any other question? I think everyone is awfully quiet, so we can come back to questions as well. So if anyone wants to ask any questions, oh, there is one question. So Pallab Kumar Moitro has a question. So maybe you can unmute yourself and then tell the question, Pallab. Okay, maybe.
Yeah. Yeah. Hi.
I'm Arnold here. Sir, I have a question that regarding in one of the slides you said that any database of the videos of highways of Dhaka could be great. Could you share some more light on it?
So I mean, if you are familiar with deep learning, there are different types of learning mechanism, right? So if you only have a video of the like of the streets of Dhaka, say an egocentric video, say you have a car and you have a camera in front of the car to capture all the videos of the roads you are driving through, then first of all, I don't know if there are many annotated data sets or even any data set on that sort of videos. So even if it is annotated, people will be able to use it as a test benchmark. Say I train my network to do pedestrian detection or object detection or semantic segmentation of the scene on some other like well annotated data set, and I'll be able to show how that performs uh, on the streets of Dhaka. And if I train on the US roads, of course, it will not be able to probably detect a rickshaw on the street. So that would automatically uh, pose a new problem, show the vulnerability of that other algorithm that was not trained on these sort of scenarios. Also in the streets of Dhaka, you'll expect a lot more people, a lot more anomalous situations. So it is very important to understand and find all the corner cases for an autonomous car to kind of react to all sorts of anomalous situation. So that goes for unannotated data, but if you can collect the data set and also annotate it for every object, every person in the scene, annotate like saying like, okay, this pixels belong to person one, this pixel belong to another person, that is those pixels belong to sky. So semantically segment the whole scene for every frame or at least some frames, then that you can even use that data to train a stronger model that would also be able to work on scenarios that you see in the streets of Dhaka. So that's going to be a start. I mean, if you think carefully, so right now, even in US streets, autonomous driving is not like 100% perfect, right? Unless you have a separate lane or separate highway for autonomous cars, accidents are kind of bound to happen because in the training data set, not all sorts of all sorts of anomalies are taken care of. So, so I think you can easily contribute to that type of research to detect to understand the scene, to semantically segment a scene by providing this more challenging data on the Dhaka city roads. Yeah, I guess, does that answer your question?
Thank you, sir, for the answer. Sir, I have a second question that you talked a lot about the biases that may be present in different databases. I normally work with biomedical signals, and during this period of time, I see lots of paper on COVID detecting from X-ray are coming out
Yeah.
using computer vision technique. But I do think there are biases, machine biases in the databases and others. And
Mhm.
as a researcher, how would you actually evaluate your performance on base of this bias, or how to eradicate these biases from a researcher point of view?
Yeah. So one, so for example, okay. So I can give you an example of how you can reduce bias. Say one thing is you can say you have limited, say for example, say you are doing, you are classifying, you are trying to classify people according to their age, right? So you have a big data set of people's faces and you are trying to estimate their age. But of course, in many such databases, you'll see that there are not many samples of a very old age, like people above 80, or neonates, like or maybe kids under 5. So those two classes will have much less data than all the classes in between, right? So then uh, then that obviously, if you just train with that data, the network will have a certain bias to say that, like, it will not usually say anyone is above 80 or anyone is below 5. It will kind of get biased to all to those samples that are more prevalent in the original data set. So then there are techniques to kind of force the network to learn a feature uh, uh, that that maybe like use some sort of class balancing technique when you train the network, or sampling technique to sample more information from the classes that has less level data. That's one way probably to kind of make the playing ground equal for everything, for all the classes. Similar thing happened, I think, in many face data sets. There are not many examples of African American faces compared to the number of like white American people's face, and that's what kind of probably led to the misidentification of like people with color in many recent police incidents. And to prevent that, one way is to either get more data on those classes, or change your training pipeline in such a way that you kind of balance it out for the network, so you don't let the network get away with predicting things that are more prevalent in the data set while neglecting things that are less prevalent. You have to make the playing field leveled out for all classes in your in your data set. For COVID-19, I specifically know that, so compared to the amount of data you have for healthy people, the amount of data you have for COVID-19 affected patient is much less. And also it might have some sort of like some sort of bias related to from which country you got that data from. Like if your regular people are all from all over the world, and all your COVID-19 patient data is from say the early occurrence, like from Wuhan or China, then it's possible that the network might learn something entirely different to differentiate between these two sets of data, right? As you mentioned, there might be even bias from the machine that captured this data. So something else might give away that those are from one sort of machine, and all the rest are from another type of machine. So on that also, that explainable AI concept comes. Like, so we want the network to not only say that I think this is a COVID-19 patient's data, we also should want the machine to say why it thinks that, which part of the X-ray or CT scan did it focus on to say that this person is has the COVID-19. Is it some sort of machine noise that it is looking at, or is it actually the portion of the lung in the scene it focused on to say that the person has COVID-19?
Yeah, thank you so much, Upal, for the very detailed answer. And I can see in the guest list, we have, you were talking to Arnav, who's actually also Professor Anwar Fattah Sar's student, and Upal's master's thesis supervisor, Dr. Sheikh Anwar Fattah Sar, is in the guest list, I can see. So I would request Sar to unmute himself and say a few words, if it's okay. Sir, are you there? I don't know, like there might be some connectivity issues as well. So also there was one question from Tasina Mahmood. So she asked how we can contribute to these technologies. So she's a graduate student of computer science. So this is her question.
Yeah, as I mentioned, so one easy way to get involved is probably to collect data and contribute data, and it kind of starts with that. I'm familiar with a few Chinese companies. They are actually, their job is only to collect data for bigger companies, and when you say collecting data, it actually automatically involves a lot of other things that are directly related to computer vision. Say if you want to collect face related data, then you'd also want to kind of annotate it for all sorts of facial landmarks, maybe age, gender, facial attributes, this sort of thing. So, and to automate that process, if you collect like millions of face images, it's not very easy to annotate that. So even annotating the data itself is a challenge. It's a computer vision challenge. How you semi-automate this process to annotate large number of images. You probably run an off-the-shelf face detector at first, and then off-the-shelf facial landmark detector, and then you create a framework for the annotators to correct on top of that, something like that. So that's how you can probably start. Also, there are so many so many problems. I mean, you'd have to keep yourself updated, see what sort of technology are expected to come, and then maybe focus on areas where where not many researchers are working on. Things like reinforcement learning on artificial general intelligence are also getting very popular, and these are very interesting problems. In many cases doesn't require like too much computing power. You might also be able to contribute in those areas. And on top of that, traditional machine learning algorithms are still valid. You don't always have to do deep neural networks. In many cases, it's important to find a very interesting problem then going into just going into the black box deep neural network solution. So yeah, I'd say you'll have to explore and be more innovative.
Sir, I have a question. Sir, I'm Anindo. Thank you, sir, for the very intuitive show. Sir, my question is, do you think that computer vision might have a significant future in the agricultural sector of Bangladesh, like where we may use the satellite image processing to analyze the fertility or condition of the land?
Definitely, definitely. In fact, not only that, I think, I mean, there are research works going on to say if you develop a phone app for the farmers, which they can use to take the photo of the leaf of a plant, and it will automatically tell them if that leaf is healthy or if it has some sort of infection. There has been research going on that. Like in many cases, so basically you'll have to be machine learning are basically, or computer vision gives you tools, and if you can find out effective use cases of those tools, you can definitely help in almost any sector. So in agriculture, as you mentioned, satellite imagery to find out like the status of agricultural lands can be very vital information, as well as kind of have some estimate about the products. Also,
yes, sir. I'm trying to
like
estimate the rice production, like after a natural calamity like flood, which may impact the relief management or economic management of a specific region.
Yeah. Okay. Yeah. Very relevant. It is definitely. So that is what I'm kind of trying to say, that you have to be, if you think a bit, you'll probably find a lot more use cases of computer vision in every sector, specifically in agriculture. I know that there are such technologies being developed like outside Bangladesh. I'm sure people in Bangladesh are also obviously working on those. But as I mentioned, even if you think about it closely, if you want to detect, differentiate between an infected plant leaves that are healthy for some plant that only grows in Bangladesh, you have to collect that data. you cannot expect that some people from somewhere else. So some sort of mango only grows in Bangladesh. To develop an app for that, you will have to do the field work to collect reliable data, annotate it, to train a machine learning or computer vision algorithm to do the job for you, right? So yeah, thanks for that question. Actually, yeah, it's a definitely a very big area where computer vision can play a role.
Yeah, thank you so much, sir.
Yeah, no problem.
Sir, this is Tahsin Mostafis, and my question is, in your slides, you talked about generative adversarial network that can produce real-looking images using neural style transfer algorithms or like different type of generative adversarial GAN algorithms. So my question is, can we use this GAN algorithm for generating synthetic data that can be realistic, and maybe we can use this for solving class imbalance? Like if there is a class in which there is not less data available compared to the other classes in the data set. So maybe we can we use this algorithm for increasing the number of images for the particular class, or maybe we can.
Yeah, I think I got your point. So you're saying, say, a data set has few samples of a certain class. Can you use GANs to generate more samples for that certain class, right?
Yes.
But think carefully. A GAN actually uses this generator discriminator setup, right? And the discriminator basically discriminates between real and generated data. The GAN's generated data actually has a bias from the real data that you are using. So if your real data has some sort of bias, the GAN's generated data will probably have similar type of bias. But yes, but if you do a conditional GAN to generate samples for one particular class more and more, I guess, yeah, it can probably, so these are the type of techniques you can definitely try out and see. And in many cases, I know about works where they did show that adding synthetic data from GANs, because GANs are becoming very, very efficient nowadays. They can produce really realistic looking images. So of course, yeah, that can be a very nice way to go about it, but you'll have to model that the framework nicely to make sure that the GAN itself is not biased by some sort of bias in the real data set.
Thank you very much for this answer. And also, I have a second part of this question. So if we can fine tune a model, then maybe we can use this algorithm for like domain adaptation techniques. For example, you are talking about cars, driverless cars, automated cars. So that can be driven using, so for example, if I have a model that is trained on the roads of the USA, and maybe I want to use this particular car in Bangladesh roads, in maybe Dhaka or Chittagong roads. So there are a lot of different sort of vehicles, right? Rickshaws, and like their structure is a lot different from the vehicles in USA. So my question is, maybe we can generate some synthetic data, or like maybe we can generate some 3D model, or like we can use some AutoCAD or this sort of tools to generate some three-dimensional models of rickshaw and different vehicles that are available in Bangladesh. And maybe we can use some domain adaptation technique that can transfer.
You can use a GAN to add some sort of realism to it. There has been research on that, adding realism to a synthetic scene.
Yes, that I was talking about. I mean, how effective that could be. I mean, that would reduce the time to collect so much more data in Bangladesh, and also it will make the training process much faster.
True, but so interestingly, in automotive industry, it is also important that so you know, accidents or anomalous conditions, the occurrence of accidents or anomalous condition is actually a very small percentage comparing to all sorts of driving scenarios. So in autonomous industry, that they actually, the ultimate target is to make sure that you never have an accident, right?
Yes.
So even 99%, if you only have accident 1% time, that might also not be acceptable. So I understand that, yeah, training on a synthetic environment, there are actually many research groups that are simulating driving environments and kind of training it. But personally, I think the best option is to have some sort of real data. So it can, I mean, it cannot be all synthetic, because all synthetic, if you give all synthetic data to a learning agent, then there is also possibility that it might not learn, it might learn something else, like some sort of noise to might give out that this is a synthetic environment or this does not apply in reality. Say, so for example, say you want to, for example, people tried augmenting face data sets with synthetic faces and then added realism to it and added to it. But still, the best performing methods in most cases actually, I guess, they getting trained on real data is something that can really make a difference. But yeah, some sort of transfer learning or domain adaptation is definitely needed. I mean, you cannot only train on the roads of Dhaka, then you'll need a much bigger training set. But if you have a pre-trained model trained on US roads and you have some annotated data, some synthetic data covering the scenario in Dhaka roads, then that you can probably train a like reliable model that way. Yeah, that I'd say that's a very interesting way to go, and I know that many companies are even considering. In fact, I think I know that in Korea they even created a whole city just to train their autonomous driving cars. To kind of simulate. It's not entirely synthetic. It's just it's a real city, but everything is fake. So yeah, people are trying in all different ways, and yeah, I agree. Yeah, that's a one way to go about it.
That's very interesting. I'm really intrigued by knowing the fact about this Korea, their software simulation tool. I'd like to have a hands-on experience on that if I have a chance. So thank you very much.
No, it's not a software simulation. It's I think, yeah, if I'm not mistaken, it was, yeah, like it's an entire city, but it's a fake city. Basically, they simulate, they have like simulated, like dummy people, dummy objects on the road, and they capture more data from that, basically, right? Also, think about also reinforcement learning is something that might be very interesting in this regard, because there has been research going on training a driving agent. If you just feed it information and if you have a mechanism to give it feedback about whether it did an accident or not, it's also possible that you can probably incorporate a reinforcement learning agent to kind of improve your performance. So yeah.
Okay, I understand, and thank you.
Yeah. Okay.
Any more questions from audience?
Sir, I have a question. I am Rajesh, and I currently work. And currently, I am working in telecommunication industry in Bangladesh, and you know that for the implementation of the CV, we have to work on the field level and have to rely on the network infrastructure. And currently, frankly speaking, Bangladesh network is good, mobile network, but not that much good. Like for the purpose of latency or other jitter qualities, or something like that. And what is the minimum requirement to make this visible or feasible in the in Bangladesh?
First of all, I think so the question is about the framework, right? Like the maybe an edge device communicating with a cloud, and are you asking about how we can make the computer vision tools to work on real time? Is that
Yes, sir, real time.
So I mean, for example, I had I had one video on Boundless XR, right? So the similar concept probably applies for other things. So it's basically edge computing is becoming more and more popular nowadays. The idea is, for example, say I have a phone. So my phone, so one option, so I want, when I take a photo with my phone, the phone shows the detected face bounding box, right? You probably have already experienced it. When you try to take a photo with a smartphone, you see a bounding box.
Yep, sir.
Now, what happens is, now the decision is, where do you run the face detection algorithm? Do you take the image, pass it to the cloud, get the face detection done there, and then expect it to return the results and show the box? Or do you do it on the phone itself? So the answer to your question depends on like how you want to design your framework. Basically, if it's a job that can be done locally on the edge device, and on that topic, actually Qualcomm is kind of a market leader on this, because this Snapdragon chip on the like most of the Android phones, and yeah, I mean, it's the most widely used processor for smartphones. It is, they are adding more computational power. Like it already has like GPU in the premium tier. It has like GPU and like computer vision processing engine. And the idea is the phone will do some processing on the device itself. And if it is a heavy processing task, then it will kind of communicate with the cloud and do it like maybe partially on the edge device or partially on the cloud. So from Bangladesh's perspective, so even computer vision has something to do in here. If you can develop algorithms that requires low compute, low number of parameters, you can even implement kind of like smaller neural networks on a phone chip, on a Snapdragon chip, and run it on the edge device. So so to answer your question, I would say you need to look at the framework and determine, maybe divide the tasks, partially some of them to do on the edge and the rest to do on the cloud. And for that, develop kind of like more efficient computer vision algorithms that can be like kind of implemented and ran on the edge devices.
Sir, I got a point, sir.
Thank you very much. I'm sorry, I had to attend to another urgent phone call, so I had to sign up for a bit. So we now have Dr. Sheikh Anwar Fattah sir among us. So he's Upal's thesis advisor. So I would like to invite sir to turn on his microphone and tell a little bit.
Sorry, I mean, I had another event. First of you, Upal, I love to see you here, at least in front.
Yeah, great to see you, sir.
Yeah, so it's very, very nice to see you with our students, because a speaker like you a passionate volunteer like you to give something always to our nation, to our students. I mean, I know your feelings. Whenever you are delivering something, it's not like just delivering a class. It's something you want really to give something to our community. Uh, Thank you. I was actually, I had another event, so I was just looking your screen. So I saw some slides, very effective slides. And maybe I have a lot of questions because I was supposed to have sessions with you because we are now working in deep learning, and you worked before, long before you suggested us to step into this area. One thing, just it's a I should say maybe a top level question. I am just feeling, my feelings is that, like, we are using deep learning. So the first layer, even if we give any input, an image or 1D signal, the next couple of layers we are using some sort of convolution or some sort of neural network actions. So what is happening if I compare your input, and previously we used to have different types of transform. Let's see, wavelet transform or different transform, and getting a alternate representation of your same image, and then do some sort of feature extraction. But now all of we are just playing with the intermediate architectures in different way and getting same feature vectors. My question is now, do you think that those type of approaches where we had even now work going on and very strong transforms will be obsolete or no use? Or we can use the transform versions and then can start again in a parallel path?
So the thing is, I think in traditional machine learning, first of all, really glad to see you, sir. Thank you very much. Actually, I think the transforms were more explainable. That's why they were popular. Like in traditional machine learning, all the time the goal was to kind of use some sort of explainable transformation on the image to take them into a domain where it is still explainable what's happening. In deep learning, that thing changed. Now, actually, why deep learning still works is still a big question. There is no clear-cut answer to it. And also, we cannot expect to understand the high dimensional feature that the network is giving us, because only because the network actually sees the image in some other way. We can probably say that it just explains the image in a way that the humans cannot directly comprehend. So that's why the entire field of explainable machine learning is there, and we are trying to kind of figure out why the machine take the decision. But still, we are not being able to describe what each feature vector in the high dimensional feature vector actually mean, because you can simply think that this is not explainable to the humans in a human level. The machine sees in some really big high dimensional feature space. So some dimensional space where we probably cannot easily see things. That being said, I don't think the transformations will be obsolete, especially if you can find, say, if you know that knowing the frequency domain transform of a signal makes it pretty obvious to do some sort of classification, then providing, so that's a higher level information for the humans. If you can provide that to the machine can build on top of that. But it is not exactly necessary to provide the machine. If you don't provide it, the machine will learn it in some other way. It will not exactly do a frequency domain transform, but it will do something else, some nonlinear equation it is learning just to get to the same result. Or maybe in many cases, you'll see that it would probably outperform if you just only use frequency domain transform and use some traditional machine learning algorithm. But again, if you can provide the frequency domain or that transform domain response that you know will help to get to the decision, then I guess providing it to the machine will allow you to reduce the size of the deep neural network. The network probably can adapt to that same level of performance with less parameters and less compute. So I guess that's where we are, but yeah.
Yeah, exactly. The word explainable is rightly you pointed out. And also you rightly pointed out another thing. Yes, we tried. I mean, okay, you give the original one, and we had one transaction paper in the second round review. Hopefully it will be accepted with Professor Isai Kum, Princeton. So he also agreed to be one of the co-authors. So because last couple of years, the fight was like that. What is the use of inputting a machine transform function? You rightly pointed out, but I still believe maybe that can give a machine a separate approach. Maybe the machine can even perform better if you, on top of the regular, we just did that things like different transform in parallel we pass with the original one and showed that okay, the original one maybe 90%, and if you add different transforms, it gives you a better opportunity for the machine to have a better accuracy.
Yeah, in fact, I think that probably gives you a way to so like compacting the deep neural network is now a big research area, right? Like you don't always want to use a ResNet or DenseNet or VGG. If your problem does not require you to use a VGG, you're only using it for the pre-trained weights, maybe to easily get to the level of performance. But if you know that some sort of transform, so it can be a mix of traditional and machine learning and deep neural network to actually reduce to a smaller network by providing some insight to the machine from the traditional knowledge, like traditional transformation technique. That I think is a way to go about it. Yeah.
Thank you. Yeah. We need a separate session with you for our a lot of students. Thanks, Sajid, to have wonderful platform. Yeah, you two people are friends, I know, but even it's a good thing sometimes to call your friends who is very useful for the community, rightly. For the
Thanks, Sajid.
I mean, for Upal, I originally intended not to invite him in the Meet the Young Professional. I wanted him to give a day-long workshop on machine learning specifically.
Yeah, it should be.
So, but he needs more time to prepare on that.
Yeah,
and he agreed that.
I at first agreed to that, but then I thought, I mean, I need more preparation. I mean, you need some material to do a day-long workshop, but I think this is probably kind of gives you some background on
Thank you, Paul. I just want to talk a little bit about some of our upcoming events in the next month. So as you know, we have Upal today. We would also feature Imran Mohammad Amin on July 22nd, and hopefully on July 25th, we'll have Imdadullah and Nurul Islam. The idea of this Meet the Young Professional series is we invite the people who were part of our YP affinity group previously and who are now working in different industries to bring them here and learn more about their particular field of work. And we also have a young professional meetup planned on August 8th. We'll give more details about this event. And we have an idea contest planned. We'll announce the details of it. So this would be, we invite regarding how you can fight COVID or the post-COVID impacts, and then write a 2-page idea, a unique idea, and participate in the contest. And also we are planning to invite Professor Christine Sainani for a October 16th or 17th workshop to specifically talk about improving scientific writing. So these are some of our activities planned for the Young Professional Affinity Group. So I just wanted to share these, and hopefully if Paul manages to prepare his presentation, I would definitely love to have it while I'm the chair of the Young Professional Affinity Group. So I would like to invite everyone to turn on their webcams. We want to have a group photo in Zoom. So if you could please turn on your webcams for a brief moment so that we can take a screenshot.